In hacking, everything could be hacked, but it depends how hard I try.
With software, it's easy to iterate. Like you write a small piece, you see if it works. You write another small piece, you see if it works.
Quantum computing that we hear, it's marketing. The quantum computing, the real one, it's another type of computers.
Especially when it comes to software, the hardness has to do with the scale of the software.
Engineer is the guy who understands how it works, understands why it works, and how he can change it.
A lot of companies just need monkeys.
A lot of guys like this courses, like 1 month and you'll be senior developer.
Okay, we are quite prosperous as a nation, but we have weak people, dumb people.
I'll create the idea. They will give me money. No, nobody will give you money. You should work hard.
You kind of have to pick your poison. It's hard to be poor. It's hard to have a 9 to 5, but it's also hard to be an entrepreneur.
You'll get money only when you can prove that you can create this product, because an idea have everybody.
Yeah, anyone can code nowadays with AI.
You just don't want to learn. That's the point, in my opinion.
Hello and welcome to yet another episode of VUnstaged, the After Hours edition. And with me, I have yet another special guest, somebody I met at a conference, and I thought his presentation was really cool. That's why I decided to invite him over. So without too much blabbing, because it's an After Hours show, I will hand it over to my guest. So if you can tell us, for those who don't know, your name, what do you do for a living, and of course, how did you get into tech, as everybody has their own unique, interesting story.
Hello, I'm Artur. I have my company, Pen Engineering. We are doing outsourcing, outstaffing projects and our own projects in embedded systems, IoT, and hardware. We have our partners in China and across the Europe to produce PCBs and stuff. We have like one of our open source projects is a hacker toolkit and a gaming console with our custom operating system and other NDA projects for clients. And at 14 years old, like I was impressed by making a Tesla coil.
14 years old.
Yeah. So I had a relative who was an engineer in the Soviet Union. He had a lot of books of electrical engineering, and I started with electronics engineering, like some integrated circuits and so on. But I understood very fast that having an Arduino to blink an LED is like 5 lines of code instead of 5 hours trying to get an integrated circuit to get the same LED blinking. So that's how I started. Like at 16, I was.
So did you attend like some kind of? Because nowadays we have like all these kinds of micro lab.
No.
Environments where people like send their kids to, and then
No. I was at something like this, but when I had my company, and it's more like for parents to think, okay, I gave my kid there, he's going there, and I think it's nice. That's more for the parents than for the kid, because
but 14 years old is so damn young.
Yeah, I guess everyone can understand this. Like for me, every topic from software engineering, from embedded engineering and electronics engineering is like, you should know the basics and you can understand this.
So you started right from that? Because I wanted to ask, how did you get into embedded engineering? Was it software before that, or?
No. I started from hardware.
Yeah.
I started hardware engineering, and after this, as I said, I understood that software in hardware is nowadays very popular and important, and started coding in C and C++.
Damn, you're like the perfect, I don't know, the perfect career path, I guess, because not everyone starts with, like, people usually start with C. At least it was my experience, because I finished like humanitarian profile at high school. And people, like, when they get stumbled across C, it's like such a nightmare, because you have to deal with memory, you have to do everything manually.
Yeah.
Everything is so slow, and you're like, why the fuck can I define the string like in other languages? Everything has to be so manually done.
As I said, like, to 14 years, in my understanding, if you know the basics, like how it works on the lowest level, you can do anything. And that's why a lot of software engineers don't like C, because you like on your shoulders is everything. C is like, I give you the toolkits, and with this toolkit, with this very small toolkit actually, because if we go to learn some tiny ML or any machine learning stuff in Python, you have to learn a lot of words. Like I can write a very big book with
Just buzzwords.
every keyword in Python. In C, it's like a very small book, will be a booklet, I can say.
I don't know about that, man, because
Yeah, and
I don't know about that because my kickstart with C was like a huge book. I'm like, where the fuck do I start?
yeah, in C actually you have a very small, like not a lot of keywords, but you should understand.
Gotchas.
Yeah, you should understand everything you do. If you want a queue, you should create it. You
Yeah.
should code it. If you want a variable length array, you should code it, because it's everything on you. And in embedded, it's much harder, like in from this point of view, because you can have not only Windows will say that can be,
Yeah.
and that's an error. You'll
Yeah.
have like just a Stack Overflow, and that's a hard fault which breaks out the microcontroller.
Yeah. More on that, like, because I'm still stuck on the 14 years old stuff. Like, what's the concepts? Like, what are the concepts that didn't click for you at 14? Because when you're young, you don't understand everything.
Yeah, but I started like from not from the very hard books. I started from physics as
Yeah.
it is, and I started from what if I take the like very strong battery 12 volt 12.
So just circuits and stuff
Yeah,
like
yeah,
that?
that's just circuits and understanding how it works. And after you understand, because at university, as one of our teachers said, I'm learning this stuff like half of my life, and they are trying to give you all this information in half of the year. I'll give you like just the marks because you can't understand it. You can learn it, you can't understand it. And I was trying to understand it because I had all my time in the life. I was not looking how to get a job, where I should start. I was not looking where I should start or what I'm starting. I was just got interested and was just researching.
I mean, most people in, I don't know, 14 is like 7th, 8th grade.
Yeah, something
Yeah,
like
most
this.
people that age, they don't give a shit about like studies, and they just want to have fun until like you get to high school. Then you really start like considering what's your career gonna be and shit like that. And I would say you started like really young, knew what you wanted to do. And for me, when it comes to, because you mentioned physics, for me, when it comes to physics, like the basic circuitry stuff, and then when you go back to university, like learning different kinds of law, like Kirchhoff law and stuff like that, I only started realizing, oh, this actually makes sense when I started doing my like first soldering and like putting up an FPV drone. I'm like, oh, this fucking makes sense because now I broke it and I created a short.
Actually, that's the problem because I was researching, I saw a thing, and when I was just like studying about the Ohm law, the Kirchhoff law, and Ampere law, so on, I was like, oh, I saw this already. But in university, when you go, you're like, okay, this thing is a thing that I can just apply the formula, and actually that some kind of works. But for real, you should first see how it works, see the path, how the guy who like for example Ohm, how Ohm understood and get to this law.
Yeah,
But they are trying to like when you learn and when you understand something, the two very different things.
how did you bridge the disconnect between theory and practice? Because especially when it comes to hardware, you don't have like, when it comes to software, I like talking to you, I realized how privileged I am to write software because there's so many abstractions. You have a laptop, you can do anything. When it comes to hardware, you need actual devices, and you also need to be careful how you debug them, which we'll talk about.
Yeah,
So how did you bridge the gap between theory and practice? In schools, university included, there's a lot of theory, and you get to practice a little bit at like labs and stuff.
Yeah, but I started practicing by myself. Like I was going at Tichka and buying
So you
stuff
bought
from
like
Alex. Yeah,
parts?
buying stuff from AliExpress, and I was just boarding a lot of PCBs. Yeah, for example, if I would start the same path right now with my knowledge, I would not burn any of these things. But if I like if we go back days, then I can say I burned like 70% of all PCBs I had.
Most of the parts you see on the table, by the way, are burned.
Yeah,
Some of them because of my fuck ups when I was soldering, others because I was just cranking the amperage way too high when I wasn't supposed to. And it happens with the drones because you have like ESCs, which is like electronic speed controller, and if you don't like let's say manage your power consumption properly, you eventually break them inevitably.
That is actually nice. What I like about C, about embedded, and about electronics, because the most interesting, like I was Googling something, I want to create this circuit, I'm trying to do this on a breadboard, and I have blowing up some transistor, like some voltage divider, and I was like,
I need to buy it again.
no, like, okay, I need to buy it again, but I'll do the same thing and I'll get the same stuff. I'll get the same burned, blown up components. Why? And that's
like this is, I don't know. When it comes to software, it's like, okay, let me rerun it. Like there's no, let's say, there's a lot of room for failure. When it comes to this, you need to fucking, especially given the fact that we live in Moldova, you need to fucking order this part. It's not accessible on all stores. You order it, you wait a few weeks until it comes, and then you try the same stupid mistake again, maybe change something. But like the amount of, I guess, research you do after you burn something,
it's very big, because you have like 2 months before it comes back. But this taught me to buy all the time, like 300%.
I always buy backup, always.
I know, I buy not only backup, but backup for backup too.
Yeah.
Like if I need one board, like one voltage divider, I'll have 6 of them. Yes.
And it's so frustrating because like with software, it's easy to debug. Like you put like a bunch of prints, a bunch of debugs, and you can see like the breakpoints where it's breaking. With this, you don't know whether the part came broken, whether you fucked up, whether you got some noise in the system. I don't know. Like
actually, like the part got broken. It's, you should think like where I fucked up, and if all these things that where you could be wrong, then maybe part could be broken, but you should research all these things. But I think that's more interesting than in software.
Sometimes it's partially broken, if you know what I mean. Like you buy something new and you're totally new to the experience. For example, I bought a VTX. It's like a chip for like receiving and transmitting video signals for the goggles.
Yeah, but again, you buy the full model with all on the PCB with everything soldered. When you're creating the circuit by yourself, you're buying like only the integrated circuit apart, everything apart, like resistors and capacitors. And when you buy a resistor and a capacitor, there's chance it to be broken from the manufacturer very low. Integrated circuit, it's also very low chance. That's why when you're creating the circuit by yourself, you have a lot of interesting stuff to do.
It's like buying a brick. There's no, like, that's the smallest unit you can possibly buy.
Yeah.
So it's chances of it being but yeah, it's true what you're saying. But still, like, you buy something, like, I would assume not all the components you buy are like unitary components. Some of them are like modules which are reassembled. So you don't want to waste your time.
Rarely, but yes.
Yeah, interesting. So
mostly right now, like for last 4 or 5 years, everything we are creating. Like if we buy something like pre-assembled, it's like an evaluation kit from ST Microelectronics. And for example, for a project we have right now, the evaluation kit was sent directly by manufacturer, because like we're partners. And in any case, I can send it to them and say, give me please the reference design and the PCB, how the PCB is designed. I want to see. That's my problem. That's my fault. If it's your fault, the fault of the manufacturer, I'll send them and they'll fix it very fast and we'll get a new one.
Do you normally just buy the MCU and everything else is just unitary components like transistors, capacitors?
MCU is also a unitary component, like the integrated, only the MCU. We solder it.
So you buy just the CPU?
Yeah, we buy just the microcontroller and solder it. If, like, for example, we start now a project and we need the ESP32 for this drone.
Yeah.
So we take an evaluation board from the chip manufacturer to test the software, while the hardware team or the hardware designers are creating our own hardware. And we buy the chip separately and all the stuff. We solder this and try it out on the board.
So you create your own PCB with the proper ports, connections and whatnot, and then you just buy the MCU separately.
Yeah, and we buy all the components.
That's actually smart, but I would say that's like next level shit for me personally, because you'd have to like make sure you properly connect. And if you have like a flaw in your PCB, I
Yeah,
guess
no,
it's
like in the PCB design is very hard because if you have like something for drones or FPV, you have antennas and so on, and you have to calculate the
yeah,
impedance.
it doesn't make sense to
Yeah,
just
all the stuff.
like 40-50 bucks just buy a full flight controller. It's gonna do everything.
Yeah, but we are creating this for a client and they need it. Like they want to
Yeah,
create
you
it in
want
like
maximum
millions.
performance, customizability and whatnot. Yeah, like there's so many questions in my head right now because like do you typically do you have like just you just do the PCB layout and then you order it to be printed somewhere, or like how does
Yeah,
it
we
work
do
usually?
the schematic. After this, the PCB layout, and we send the Gerber files to the our one of our partners in Europe or in China, depending on the client, and to design to manufacture them, and they this to us. But most of the time, we solder it ourselves.
Yeah, because
And
I
the
was
first
I was
version,
wondering how do you get from the, let's call it the prototyping phase to the mass production phase? You I guess need to have a way to be testing your iterations, right?
yeah, but depending if that's a research and development project where we have the possibility to have like free two types of like not types but revisions of PCB, we can go with 3 to 5 for example revisions of PCB, create them, and the fifth revision will not have any debug stuff, anything. Like you just programmed it and have some, maybe you have some logs via wireless connection or via wired connection how you programmed it, but it happens when the client needs like first revision of PCB is like the mass production one. That's rarely, very rare, but it can be
I'm just
also.
wondering, like if you experience that and if that happens a lot in the industry, like when you, let's say, iterate something locally and then you decide to mass produce it, like is there a difference or something you haven't seen in the development phase, and then you mass produce it and you mass produce a huge fuck up?
No, that's barely impossible because like you can do all the tests before you go to the mass production. You do a lot of tests. Same as with software, you do a lot of tests, but in software, if you deploy it
I
and
mean, the
yeah,
the,
and
the
that
privilege with
fails,
software, the privilege is you can deploy some shit just to do the market validation, just to land on
yeah,
the
but
market.
here it's not possible. Like you create the PCB, you do like 2 months of testings to see. But if I drop it down, but if I go with not 5 ampere but 3 ampere, it's will it be brown out or will be too much volt? Not too much volt, too much current.
Yeah, yeah.
And if I'll try to make it work in a fridge, if I'm trying to make it work in an oven, like the one of the standards to get electronic piece of electronics in Europe is like the temperature level, if it can work from -2 plus degrees
So you don't
Celsius.
get sued like the dumbass who put something in the oven and then sued the company because it didn't
Yeah,
resist.
yeah, very, very rude. Yeah, it can sound like this, but in Europe, are a lot of standards for electronics. That's why the IP65, it's like you have to fill with the silicon the PCB fully.
Yeah,
Like if it breaks,
yeah,
you can't go and repair it because it's already in a silicon mold.
yeah,
Yeah.
yeah. I noticed that with a lot of parts that I'm buying is they're built in such a way that you just need to replace the whole thing if it breaks. Like
Yeah,
there's
because
no way for you to fix it, unscrew something, and
Yeah, because if you like go with this flight controller,
yeah,
it's made like like this, but this you can unsolder even if
true,
something.
true,
But there are some of flight controllers that you can't unsolder anything because it's like a block.
true, true.
So this the block one can be more reliable because even if you throw it in the somewhere or it fails, it can work.
I guess it depends how customizable you want it to be.
Yeah,
It's like building a frame, for instance, for the drone. You like assemble it. If it something breaks, you can just put another part. Whereas if you bought like a one thing molded thing, for example, if some tiny thing breaks, you need to replace the whole thing. You can't. fix a small part of that.
Yeah, but in electronics, it's like more about standards, because in frame we have like you can 3D print another one, because
Yeah.
it's in frame. I guess it's cheaper to create a new one, because you have one frame, you create 1 million of this instead of creating 2 millions for 1 million pieces of product.
Yeah. Yeah.
If you want to this to be of two consisted of two parts.
Yeah. It's interesting you mentioned like testing before mass production, because it's like the reverse when it comes to software. Because with software, what matters first is you land on the market, and quality, we don't give a shit about it. And then you want to scale your product, and at that point you're like, okay, we need to
Yeah, you
hire
have that
QAs.
possibility.
You need to like focus on quality so that this product becomes better user experience, better market validation, whatnot. With hardware, it's the opposite. You need to
And
focus a
with
lot on.
embedded too, mostly.
Yeah.
Okay, with IoT, it can be that you can change the software on the fly. Like you buy, for example, a smart house controller, a hub for smart home, and if it had enabled in the software exist something like auto update or any over-the-air updates
Yeah.
and bootloader there, I, as manufacturer, can update your software, but you should give me the possibility. But okay, for example, I worked at BMW at Flash Bootloader
Yeah.
project, and there we had like for each revision of software, like more than 1,000 tests. The testing team was black boxed from us, because development team, testing team was two different outsourcing teams in no matter where in the world. So I was getting just a very big report with new tests done on my software, where they're like, you should fix this. This failed,
So
failed,
what's the,
failed.
because you mentioned IoT as a separate branch, is there like a difference between IoT and like embedded systems?
Embedded systems is like software. Okay, like we have web development,
Yeah.
it's embedded systems. Front ends with Next.js, front end with React.js, and back end with PHP, back end on
Yeah. Yeah.
Java.
Yeah.
The different things. Here, the IoT is a different IoT with C, IoT with, for example, Rust, but it's not C is the most popular. And automotive developments. This all these things are different. If I mostly it's like IoT with Yocto, IoT with Zephyr OS, IoT with a custom real-time operating system, the AutoSAR in automotive, and
It's
all
more
these
of an
things.
integration,
Yeah,
and
it's more of
embedded
like
is.
different types of, because actually all those are embedded systems. All those I will write in C, but in Zephyr OS we have one kernel with some stuff. Exists embedded Linux, and all these things are different, but are not so different as is backend and frontend, for example. Because I worked in automotive for 3 years. After this, I worked with Zephyr, with Yocto,
It's
with
more of a
embedded Linux. Yeah,
all-in-one solution, like a framework of sorts.
like a lot of different operating systems that you take and custom for your products.
Yeah, yeah, interesting.
AutoSAR, you can name it at this as framework, but that's more like methodology of not like a lot of abstractizations that you should integrate.
And
But
embedded is more like everything is done manually by yourself.
not necessarily, because a lot, like every embedded engineer has its own background of a lot of drivers and stuff already written.
How many standards do you have to forgo before a product gets massly produced and approved on the, let's say, European market?
Depends on the product. A lot depends on the product.
Is the automotive market the craziest one with the standards and stuff?
I don't think so. Maybe the biomedical is crazier. The IoT, again, IoT can have, for example, the smart hub,
Yeah.
the sensor for example, the current sensor for smart solar panels, or the simple socket switch, like you to switch your sockets or to switch the lights from your phone, will have the socket will have three standards. The current measurement will have another standards, and the smart hub will have another standards.
What's
Because this one is a high voltage stuff.
yeah.
That one is also high voltage, but monitoring stuff. You have to be sure that this monitoring is not with delta is not too big, and the information will not be corrupted. This is sending some stuff to the server, so we have to be sure about security. This stuff is not sending anything to the socket stuff is not sending anything to the server. It's just getting the info like on off. And again, this shouldn't be hacked.
How do we make sure your devices that you buy, especially the ones that are smarter and have access to Wi-Fi and stuff, they're not like I don't know, part of some kind of zombie bot network?
I know that I read
Like
already. Yeah.
your refrigerator is like participating.
I
in-
read on Reddit sometime that a guy took his coffee machine, his fridge, and a lot of other IoT stuff and created a botnet on this. And this is actually real because if I want to hack a server, that's much harder than I want to hack, for example, smart fridge.
Yeah, because they're notoriously known for weak security. There's nobody typically thinks of hacking them.
Yeah, but the guy from Reddit, it was like hardware hacking them.
Yeah.
He just disassembled, looked at the MCU, found the UART pins, and just connected with via UART-TTL connector and read the stuff. Yeah, actually, you have for if it's about not hardware hacking, but just I am with my PC like in Watch Dogs to trying to hack your fridge or your coffee machine or IP camera. It's same as hacking at server mostly
Yeah.
because nowadays we have a lot of very lightweight security protocols. AEC, SHA to 1512, and that's very possible. Like ST Microelectronics, even for the development boards done for students, has the CRC and SHA 256
Yeah.
crypto model inside the MCU already. Like that will not be a software stuff that you have to write all this crypto stuff. That is a hardware model that the only purpose of this is the calculating all these things.
Yeah, I mean that's I guess eventually going to be used for encrypted connection and whatnot. But at the same time, I guess it depends very much on the implementation. Like, because if you want to have like some smart user interface interacting with that module, then it's easy to hack it. But like if you take, for
Mm,
example, the I don't know the fucking ACs, it's really hard to like even set it up because you have to like unplug it and then you have to press a button while connecting to it. There's like a certain protocol you have to do so that you can establish a safe connection so that you can eventually remotely connect to it.
yeah, that mostly is like having a secure connection,
Yeah.
and I don't care. Me, if I want to hack your fridge, I don't care about your user interface.
You're just gonna hardware hack it and
No, for example, I don't
you
have
mean
the
hard
hardware access. Like I'm in my car, and I would try to hack your fridge
yeah.
right here. I'll go with for firstly the application, the user interface is connected to the server, and server is connected somehow to the fridge. If I can find how it's connected, because we have a lot of protocols like build neuron co-op or TCP. Yes, this in fact is UDP or TCP, but
Sniff the traffic.
yeah, not I can try to sniff the traffic, but it's not always possible because how it is created is because
You need to be on the network technically to sniff it.
not only because we have in embedded we have like for example a lightweight standard of UDP.
Yeah.
Yeah, and this is not only one. Everybody tries right now to create very secure stuff, and everybody will create a very custom, closed.
Yeah, I
mm,
noticed that with like in at least in software development, you have well standardized protocols. In here, you have all kinds of crazy protocols, some proprietary, others public, but really poorly documented.
yeah, like proprietary protocols. If you don't have the access to the protocol from the guys who have the all the like copyright for this protocol,
Yeah.
you can't know everything about this. And there are some protocols, for example, LoRa, long range protocol now is very popular, but LoRa is not technically a protocol. This is a type of communication which is created on a specific ISM band, like an RF frequency. And again, in Europe, there are 2 frequencies. In China, there are another 2 frequencies. In US, there are another 2 frequencies. Different antennas, different stuff. And how the LoRa is really used there and what type of security, what type of encryption is set, you can know only if you get the leaked data from the guys who developed it.
Have you ever broken the law when it comes to RF?
No.
Because
Of
there's
course no,
like
of course no.
I think there's like no limitation when it comes to receiving signals. You can receive about everything you want.
We can receive, actually we've done with guys the...
But transmitting it, it's like more the...
Yeah, like transmitting, it's... You can jam anything you want. Like actually jamming is not so hard. I can create with the like 2 models, one ESP32 and 2 NRF boards. Like I need 3 development boards, connect them, solder them. Like I need 40
I heard you can
minutes.
jam stuff with like the microwave.
Yeah, no, I can just create this thing, turn it on, and you will not have Wi-Fi here and any rooms in this apartment.
Yeah.
But of course, this is only in learning purpose. Yeah, the Flipper Zero is done also for only learning purpose. And
I guess you can mess with the neighbors if they're noisy or whatever.
Yes, but about all these things are very... This is not legal or illegal. Illegal is using this in a legal way, or creating some stuff to use this in a legal way. Again, the Flipper Zero, if you know this small toy with a dolphin as Tamagotchi, you can read about this. Yeah. The Flipper Zero, this is a small, this launched on Kickstarter, is a small toy with as a Tamagotchi, learning purposes.
Yeah.
If you go to GitHub and open, you can find 3 other operating systems with everything unblocked. The most popular is Flipper Zero Unleashed. Their first is, of course, their operating system with a lot of limitations. Again, after this, you have the Flipper Zero Unleashed and the Memento firmware. I personally get the Memento firmware, and with this, you can have man in the middle for any stuff like your car key, for example, and
like still the RF signature.
Yes, take the RF signature, take the NFC, take the 125 kilohertz. That's the tags from the doors.
Yeah,
and all these things are possible. You can possibly do with the Flipper Zero, and again, that's fully legal. The thing itself, like the device itself, is fully legal. How you use it and what apps do you use on those are illegal, legal or illegal can be. Again, if the iPhone was not so proprietary, and some Android also can with the NFC readers, you can read and write with the NFC by iPhone and can steal anything with this. I saw that some guys on some Chinese phone with NFC tag and with open Android OS, like it was not very encrypted. They hacked it and they used it to hack the Tesla. Yeah. Like not the Tesla, I think the BYD car. The BYD have the NFC card to open it.
Yeah, I think I've seen that.
They go with the NFC card, and this is that's a smart card, because you go first the handshake, after this some encryption, some other encryption, and only after this you get to open it.
But you need to be close, like in proximity to
copy you that. Have to go with your phone like this, and they go get with the phone like this and brute force it.
Yeah, that's...
Because nobody thought you can brute force it actually. Yeah, but how you can brute force it? Like you have to try 1 million cards. I don't know, something like this.
Yeah, I mean, brute forcing encryption is like doesn't make sense.
That's not so hard encryption because it has like 16 bytes.
You mean the NFC thing?
Yeah, the NFC thing. That thing had 16 bytes.
Yeah, but I think you need to, like, especially when you're like doing payments and stuff, you have to be in really close proximity for it to
but
work.
They got to the car at the night. Likely at the night. Like,
so they did it more like for the... like
for testing.
for
for
testing.
testing. Yeah, if
Because
they can
in
hack
real
it.
world, you'd have to, I don't know what situation you'd have to model.
That's why NFC is still popular,
Yeah.
because you can't go like from here and the NFC tag is there. You have to be like in this close.
Yeah, because like you see a bunch of videos online where people like walk with the POS terminals and trying to steal people's money and whatnot. But first of all, people like went away from from credit cards. They like have it in their phone, and then even if they did have their credit cards, you have to be super in
Yeah, you
proximity
have and
to
the
get it.
credit cards are also the NFC. And again, if you try to steal the credit card like this with the NFC reader, it's also very hard because again, first point, you can be this close all the time, and you if you want to hack it, like I can read it and I'll get only the info who is the card
Yeah,
or
yeah.
and the card number. To get the CVC and all these things, uh, and to pay with this stealed card is barely impossible, because not only the credit card is important, the important is that bank knows about this credit card.
Yeah. Also, I think they have like a, a one-time use token of sorts
Yeah,
where you have like an approved token for that transaction and then it expired. So if you try to like, but I think I've seen like I think credit card readers and whatnot where people, especially like if you're a tourist, you go visit some country and then you see these people like trying to sell you all kinds of stuff like bandanas, toys, souvenirs, and then they tell you that you can actually pay with your credit card. They can easily steal the details.
they can try it. Like
Yeah.
mostly banks are in the NFC. I think the credit cards are the most secure one, because NFC is popular because of this, as I said, and the banks are like with the tokens, with the server stuff. Like the POS should be connected to the server, should have the token. When you connect this, the server creates a connection. And if you try to go, for example, I have two POS,
Yeah. Yeah.
and the real one, I send it, so the bank send the token,
Yeah.
and they try to take it and to pay in another place with the same sum. It can be, but mostly they'll no. This is not possible.
I mean, you can
Even
still
even
decline it. There's
yeah,
like so many ways to block something from happening without authorized use.
yeah, because in this case, you're not the credit card is not the main stuff in this. The main is the server and the bank, how it handles when you can when you place your credit card to the POS. Because and again, in case of Tesla or BYD cars, they are talking the car and the card. Here is talking the POS, the card, and the bank, and the algorithm on the client server side.
So are the average normies protected from being
Yeah,
hacked?
mostly. I think mostly with the credit cards, yes. With the least protected from the NFC is in the office. You have these cards to open your door.
Yeah.
A lot of them have the one level encryption, and the Flipper Zero you can just place it and stay like 15 minutes, and you possibly can get the access.
Yeah. What about smart houses?
In hacking, everything could be hacked,
Yeah.
but it depends how hard I try. For example, some devices like socket from China,
Yeah.
I can hack it very fast. Like I believe that this is not very tight encrypted. If or I get to connect to your network, and if this is VPA2 security, I'll get connected very fast. Like give me 15 minutes and I'll get the password. And you know how this how to do this, because the internet is full of how to, in learning purpose, get the password of the VPA2 connection to
Yeah.
network. And after this, if the socket is connected to the Wi-Fi, you go to with the Wireshark, and that's all. If that's not possible, we can get not the Wi-Fi sniffer, but the RF sniffer and try to decode it. But this is hard. And again, what is the purpose? If we go, all these small smart house things are not so hack, are not a lot hacked, because that's no logic in this, and there's they're barely good protected, only because the protection level of the IoT devices is at this level, for example, is not the best level, We can do it better, but do we need it? Because
Yeah, they live on
if
the
I'm a
local.
hacker
Yeah.
and I understand that to hack this is barely the same stuff with hacking your phone. Why was the matter to hack some IoT device?
You'd rather have as a target to hack maybe the network of that
Yeah,
home, from which you can then get access to a bunch of other things.
yeah, and after hacking the network, like again, the socket Wi-Fi, I have to enter the network. After I enter the network, I can get what you're doing via your PC. Why
Yeah,
do I
yeah.
need your socket? Why do I need to turn off the lights? If I turn off the light, that's more like about pranking something or
Yeah, you first need to find out what's the guy up to, what he has, and then okay, let me just prank with him
yeah,
and whatever.
mostly like about unsecurity of IoT devices is when hear about this. Yeah, there are some specific cases when security is needed, but they are secure, excepting some low cost stuff from China. But even they have something like if this is not built on Arduino,
Yeah, yeah.
it's good. If this is built out of a team of hardware engineers with something really powerful, like even an STM Cortex M4, it can have the separate crypto model, and that's all we need. Because why do I need to hack this if I can
Yeah,
hack
it's too much
anything?
effort.
Yeah, too
Like,
much
what's gonna be
effort for
the
too low
reward?
outcome.
Yeah, yeah, yeah. That's right. I mean, I was always like curious into like, okay, how can I maybe get into some like just for the prank, I guess, but not sure if the effort is justified to be honest. You mentioned standards. To my mind came this. I'm not sure if you heard or not about this recent European Commission's initiative about the chargers being USB-C only, or at least
Yeah,
having
I
the
heard of this.
yeah. What's your opinion about like standards in general? Is it for the better, or should companies be allowed to maybe come up with their own standards and stuff because that's what pushes innovation onto the
Some
market?
standards are for the better because without them, I could create anything, and you don't know what you both like. If I created some stuff with 35 nanometers PCB,
Yeah,
and you try to plug it in within 2020 volts, and that will burn out your house. That's bad. This standard is good. Some standards are not so good and are created not for
but
engineering purposes, but
yeah, yeah,
for like the Type C is not for engineering
yeah. That's what I
purposes.
meant. Not like standards for safety before you even reach mass production, because those are kind of your obligation. You need to fulfill them before you are able to sell the devices. But let's say standards that are optional for like data communication, or like I don't know, let's say charging or like power consumptions. Like you can choose a wide variety of ports depending on what's going to be the power consumption for that device, and then the from that point you can go
In my
lay out.
opinion, if that's optional,
Yeah,
and I'm not Apple, why do I need any port but Type C? Like I will choose Type C because I'm not Apple. I don't have that much of power to say
yeah,
use
but
Lightning,
type
please.
C is funky because you have the state like the port type C, and you have a whole bunch of like wide variety of implementations.
That's actually the software stuff.
Yeah, and
Not only the software, but this like the Type C is a port with a lot of pins, and when you plug it in a phone, two pins will be shortened out, and
yeah,
you'll have and this will say to the adapter that this is a 5 volts stuff.
yeah,
Give me please 5 volts. When you plug it in your Apple, like MacBook, for example, and other two pins are shortened, and this says to the adapter, I need 19 volts, for example. And that's very nice. I like it because why do we need something else?
yeah.
If
But you
that's
have
okay.
you have different, let's say, power delivery slash data delivery implementations, and a lot of people are confused when they buy them because they, oh, this is super cheap, but why the fuck is this so expensive? And they can't tell the difference until you buy it, and then you have like you want to move data really fast, and you realize it's super slow, or you want to charge and you realize it's not fit for charging your MacBook, for example, or whatever.
Yeah, but that's more because of creating too much like cheaper or expensive versions. And they think,
And there's no way to regulate that because you have like the standard, which is Type C, and then you
no,
have
you have the standard, not only the Type C, the QC
The
Type C. Yeah,
certification,
yeah, that's also the standard. Like about the power delivery, about the Thunderbolt 4 is about data delivery, and all this. Also, these standards exist, and if that's harder to understand, but anyway, you can, if you go to any adapter which supports any type of Type C, you can turn it back and you'll read Thunder like QC free, which is maximum 40 watts, for example.
Yeah.
And having ChatGPT on your phone, you can get to this very fast.
Yeah, it's such a convenience, because I remember when I think when I started to do like FPV drones and stuff, my only reliable source of information was a bunch of FPV forums and YouTube. And you had to rewatch the same video so many times and like zoom in to see how the guy soldered the thing. You wouldn't have access to all this, especially when it comes to embedded. You have so many acronyms, so many letters, which mean a lot of things. Protocols, how the protocols is supposed to work. You need to read the layout diagram for that specific PCB and whatnot. And with ChatGPT, you just put it in, and it's.
I don't like ChatGPT for. I really hate ChatGPT for this. I tried sometimes, like I had the adapter board from ST Microelectronics for JTAG to software debug SVD. For debugging, I wanted to connect a board to like my board with via JTAG via this adapter board to an ST-Link to my computer. I sent it to ChatGPT and he was like, here is 5 volts, here is, yeah, not a problem. So the first pin is 5 volts, the second pin is data input, output, and the third pin is data clock. And fifth and sixth are like ground. Okay, I found, I had the real pinout was 3 and 3 volts. Ground, data clock, data input output, and ground. For example, don't matter that.
And sometimes they're inverted, and you need to like figure out. Yeah.
But ChatGPT said me that that's a 5 volt logic. I think he found some barely same stuff because I sent him a photo.
Yeah.
Barely same PCB adapter, but if you go, for example, if you go to Google the adapter name, that's a bunch of letters. You'll find 6 of them, and you'll think that that's same shit. No, for me, all of these things are different, and that's why I hate ChatGPT for this. But in some cases, it can be useful. Mostly, I like Cloud for this because when I send to Cloud a PDF file and say, find actually the PD1 pinout type, he'll find me faster than I can. But
since we opened this Pandora box of AI and whatnot, it's been 3 years almost since the AI boom and stuff. What's your opinion of AI, and what's the, because when it comes to software, a lot of effort has been put into AI. Progress has been made. People brag about this being way faster, this replacing developers and whatnot. However, when it comes to embedded, at least that's my opinion of it, is I don't think a lot has changed in this sense. Maybe a little bit of automation has been going on, but a lot of the stuff is still old school. Maybe the standards a little bit are changing, but a lot of the stuff is still the same.
Actually, I'm using the Copilot for VS Code, but I'm using the Copilot for like
But it's still for software, I would say.
Yeah, not only for software. I saw a Flux, like a CAD software with AI, but this is so bad. So if I'm creating some model very fast, like with getting 3 models wired up with 5 wires without any impedance stuff, any high voltage or standard stuff, like about standardization, I can use AI for me to say the pin mapping, for example. But no, for hardware, I don't know when it will be able to use it, because anytime I was trying to send a PDF file, like find please in datasheet what wires, what pins to what pins I should connect. It was giving me such a shit, because like it was like, if I connect this, as Cloud AI said, it will be burned out from the start.
What I noticed, at least from my small experience with dealing with FPVs, you have to rely on engineering practices and standards. Like people usually label wires certain colors. They typically have them in certain positions, and you kind of trust your gut on that one.
No,
And
in our case, we have data sheets from manufacturers, and we have to like, for example, if we go with these controllers you have here,
yeah, there is a
it
data
yeah,
sheet. Yeah, it's gonna show you each pin.
there is a data sheet for the controller,
Yeah,
which is not the data sheet I will use.
yeah,
I'll have all, for example, I'm creating this controller. So I have there, for example, 5 integrated circuits, some transistor like MOSFET transistors, and okay, 3 types of MOSFET transistors, 5 types of integrated circuits, and I'll go to find for each of them the data sheet, for each port the data sheet, and after this to create it, like to create the schematic and to create the PCB. And I'll have like 15, 50 data sheets if this is something big.
yeah. For me, it's like using an API. I guess just give me the UART pins, the date, like whatever data pins you got, and then the 5 volts, the grounds, and that's pretty much it. Because I buy a bunch of like already built parts, and I just connect them to the proper
Yeah,
UART.
and you just should know how to use the API of this and the API of this.
True,
Like
true. But you're like creating everything from scratch in that
it's
sense.
like using the library and creating this library, using
true.
the framework and creating this framework.
Yeah, can you maybe explain for the average software engineer who wants to get into embedded systems, like what's the, I don't know, maybe the hard bridge they have to gap?
They
Because
have to go to
for all of us, it seems like a lot of magic, and you need a lot of prior hardware
Mm,
slash physics slash.
not necessarily, because for me and for some of embedded engineers who are into hardware, it's okay. But there are embedded engineers on application level which are not so tight coupled. Like I'm writing drivers and operating system, real time operating systems. I'm like at kernel level and sometimes lower. But like a friend of mine, a very like actually my colleague, he's working in my company. He didn't know about how IMU works
Yeah.
at all. He was like, Artur, this shit, some shitty angles, some I don't know if that works. And I'm saying like, sorry, this works perfectly. And I can't say he is a bad engineer. He is a very good embedded engineer because he knows how to connect the drivers. He understands how the pin works. He understands how to like read from pins. So if you are a software engineer and don't want to get into hardware but only into embedded
But you have to rely on the
development,
fact that hardware works properly.
yeah.
Yeah.
But when you're on a big project, you rely on this because if the hardware doesn't work properly, that's a hardware team problem.
Yeah.
For me, when I'm managing all the flow from the hardware team, like creating the hardware and with the software team and with the hardware team, I understand.
Do you get involved in both?
Yeah, mostly, but mostly in the software development. Like I am not very bad hardware engineer, but I can say I'm a senior hardware engineer, like middle, something like this. I can create flight control like this. Will not be a problem for me to create some very very complex RF FPGA stuff. I'll be I'll create it,
You
but
still would rely on some protocol, which
yeah,
is
I will create it, but will it be very good? I say no. The FPGA stuff will be a pretty shit comparing to the one I can buy.
how much time did it take you to learn how to properly solder?
I don't know. I can see. Like I was soldering again, as I said, from the Tesla coil, and the first things I soldered was a transistor and the wires directly to this. And I was soldering first with an Soviet soldering pen,
Yeah.
a very old one and a very big one, and it
It's
was
so frustrating, especially when you have like super tiny wires and you like try to hold them with your finger and they start to hit.
No, my finger till now my fingers are mostly like as a very burned out here. And
And then you're like, oh shit, there's like helpers and stuff. You can use them.
no, even without helpers, I can solder. Like I hate this stuff because I had a lot of like these hands and to solder it, and all the time I was like,
No, I usually like
I'll take it.
tape it on like some metal plate so that it dissipates the heat. But every single time, especially like when you solder like small wires, it's one thing. It's I guess manageable. But when you have like bigger wires, like for example this XT60 connector, it starts to heat up really quickly and you cannot hold it.
Yeah. So
Yeah.
if it heats up, that's a bad thing. because the important, you should use a good soldering wire, a good flux.
Yeah.
So you get a lot of flux on this, and you should do it fast, because if you go with the integrated circuit, for example, the soldering pen you have, it has a bolt on this, and this bolt is meant to connect to your wrist and to connect to something which will not give you possibility to burn out all the stuff for the static electricity.
Yeah.
So if you're in a house with a good ground, because the AC, the alternative current have phase and zero, and the plus and minus are not actually the plus and minus, because you have the ground, the plus and the minus. The 12 volts, which you can have minus 12 volts and plus 12 volts, is at 24 volts.
Yeah.
And you have 0 volts, 12 volts, and the stuff is that all these things are not needed in electronics today, because we have all the time plus and minus, zero and positive. And that's 90% of the stuff. But for example, in some audio technique, there in very, like, not GBL, but for example in Marshall for guitar, it can have the bipolar voltage, and all these things are so rare.
Yeah, audio for me is so fucking magic all the time. Like every single time I get some kind of a noise, or like setting up the micro, like I don't understand how it works, and sometimes it would just not work for weird reasons, and it's just frustrating to deal with the noise and you don't know where it comes from. Like, how do you deal with the, like, is there noise when it comes to like designing a PCB,
Depending.
dealing with it, especially when it comes to like integrating analog to digital converters?
Speaking about like the digital circuits, are the high speed ones with the FPGA, with some DDR RAM, with DDR memory, flexible memory controllers, and all this stuff. This is a hard thing, because there you can, if you get like 5 micrometers longer than you should, you can have problems.
Yeah.
But all these things are because how you designed. In analog is like digital electronics, the stuff which is in embedded systems mostly is not so hard. If we go to the something complex, FPGA and so on, there are so much small things that you should know. You can't learn this. The thing I understood from creating some hardware pieces, like some electronic devices, you can't learn everything, because you should see this and understand this, or some guy who have a lot of experience should show this to you.
Yeah.
And about analog, this thing is a different, completely different type of electronics. Like, okay, we're using the same rules mostly, we're using the same wires mostly, but for example, I created amp for guitar, like when I was 16, and it was very noisy. It was very, very noisy, because I was powering it from the lab supply, and the lab supply was like impulse one. When I powered it from the battery, it was perfectly sounding.
Yeah, I always notice that, especially but even the battery depends, I guess, what kind of voltage comes in from the battery as well. Because if you have like a threshold where you can, let's say, supply, I don't know, from 12 to 24, that's one thing. If like the higher the voltage goes, typically the more you can like have spikes, and then you need some kind of, you need to in any case you need to have some kind of voltage
Uh,
regulator to trim it down.
About voltage regulators, if you power it from a battery,
Yeah.
the battery will go like logarithmic, like this, down the voltage. No spikes, no anything. But if you power it from the adapter is theoretically saying static current.
Yeah.
But this is not actually true. Not always true. It can be impulse static current, which is like you have 5 volts, 0, 5, 0, 5, 0. And because of this, like, technically speaking, this is a static current, but not an alternative, of course. Like, we have minus, we have plus, everything works. But again, then you need a voltage regulator with a like with not impulse voltage regulator. It's also important because if we go to an AliExpress and go to find something like I need a voltage regulator for 5 volts, most of them will be backup converters. I think you saw something like this, and backup converters are like also impulse one, because the impulse one have
So it's not going to be steady. It's not going to be static. You're
it
saying?
will be static, but it will not be like all. The battery goes like this,
Yeah.
but here you'll have like you plugged it in, and you'll have not spikes. You'll have like 5 volts for 5 microseconds and 0 volts for 1 microsecond.
Is that due to like, because I think it has like some kind of capacitor or whatever.
Not the capacitor is meant to nivellate this. It has a coil and inductance for to regulate the voltage.
Yeah.
So the regulating the voltage is a PWM controller, transistor, which is opening and closing all the time, and the inductance. And inductance is taking all the voltage, all the current inside. The capacitor is also. After this, you close the transistor, and because it's happening so fast,
Yeah.
you can't see that this is not static like current.
Yeah, if it happens slower, you would see the
Yeah,
up
you would
and down,
see.
I
Yeah,
guess.
you would see the how it like turns on and off. But when it's happening so fast, the transistor is like going to the state of. That's a special name for this when it's very fast and it's open closed like this, opening and closing very fast. And that's a backup converter, impulse one, because they are cheaper, they are faster, and the voltage you can regulate with this is very wide. Because a simple voltage regulator like the static one, which was used in Soviet and which is used in audio like audio stuff, because there something like this, like buck converters, are not allowed at all. They are much complex. They are not so easy. Because actually how the voltage regulators, the impulse ones, the block schema is like this. You need the inductance, you need the PWM controller and a transistor and a diode with a capacitor.
So you plug it directly, then there's a chance at some point you'll fry something.
No. All of those are created in such a way you can't fry it. It can have some noise, but you will not break it up.
But when it comes to frying, because you mentioned in the very beginning you fried so many chips. When it comes to frying, and since you're more involved in the software part, can you write software that fries a chip?
Yeah. If
what,
I go,
what would be
if
the main, let's call it, point of failure?
you should try to write the software to fry
I
it up.
have not. I typically
No. You should know how to fry it up, because to like from
is it like infinite for loops? Like what's
no. That's hard faults. That's
Yeah.
everything of
Yeah,
like
yeah.
this.
Because that's Stack Overflowing.
Yeah,
and
that's
whatever.
a hard fault, and you'll get in a fault state, and you'll just reset, reflash the chip, and that's okay. To break up a chip, you should go not with a hardware fault, but with some memory protection unit to fuck up this memory protection unit. And for this, I guess I can go with somehow going like
Because you have to heat it up somehow.
No. You have to go to a read-only memory zone. You have to go to register that don't allow you to write in this memory zone. To access this register via increasing, like incrementing the pointer, something like this is possible. Like for example, I have a pointer. I get not to the memory that I need that, but to the memory
You
where
extend over it.
Yeah, where is the register? Changed one byte, the specific byte in the register. After this, with another pointer, I go to another memory zone. There, I change again some specific bits, and I should know what I'm changing. Or this should be such a coincidence. But from the software, it's hard. In 32 bits microcontrollers from ST, ESP, which are widely popular right now, it's hard because all of them have memory protection unit. All of them for ESP32 have even a memory management unit where you.
I mean, most boards even have, I would say, hardware protection. Like if you have like a fuse or whatever.
Yeah. So most of them right now, it's hard. The way to from software to do this, you should have the chip itself, and you should know what you're doing. And mostly, if you write an assembly, you can do this.
Yeah.
Like the only point of this is like you have the all memory control and you have the datasheet. You know all the registers. You can take the register you want. You know that this register will not give you a hard fault, but will break up the chip, and then it can be possible. But the guys who are creating the chips are thinking about all the time of this, and there are so much stuff that is easier to just take a hammer and break it, or just somehow to plug in a 50 ampere and to burn
Yeah,
all the chip.
typically
Yeah,
more amps is always gonna burn your chip.
actually, again, not always.
Or the fuse.
Yes,
So
something it can
so is
gonna
the
burn.
fuse like the ultimate all-time saver of
No.
not breaking your?
I worked at BMW at the electric fuses stuff, like the ECU, which is meant to replace the fuses, the electric fuses. That's all.
What's a point, like a common point of failure? Because again, I know I'm asking like a generic question, but what's the most common point of failure slash frying a chip? Let's say hardware wise, not software.
For the beginners, is mostly like shorting out something. Like you have the 3 volts on the ESP32 on Arduino, and if these two pins are not somehow protected,
Separated or
you just shorten out, and that's
when it comes to as you mentioned this idea of components being so cheap to the point where it doesn't make sense to repair them. Like what components do you just throw in the trash can versus repair them?
from the development view, like from what we
Yeah.
develop.
When you work,
I can say that we throw something away. Like when for example, you have this EC,
yeah.
you can buy a new one.
I mean, it's gonna depending on what amps you want to go
Yeah,
for it.
but
It's gonna
anyway,
cost you.
it exists anywhere in the world.
Yeah.
For my PCBs, I have 5 of them, and they are produced for me, for our development team, and the mass production will begin. I don't know where, and then how it will begin. So I have only the 5 PCBs.
So you need to work with what you have, basically.
Yeah, I'm working with what I have.
So you basically can't start working on it unless you have like the minimum amount printed, and then you put stuff on it. You can't just like do it by hand or whatever. Because I'm not exactly sure. Because typically this is done in factories. You like order,
The
you give them the
assembly.
layout, and then they give you back the boards.
Yeah, they give you back the board. Like they give you the boards, and you can assemble them, or you order the PCB. You order the PCB assembly. You
Yeah.
can assemble them on the factory or assemble by your hand. Whereas, like a lot of times, I have the 4 PCBs to assemble, to disassemble, two not assembled, and we assemble them by ourselves. And if this is a project of mine, and that's all, like, and I'm going to work with this. If I have something broken, like a resistor or okay, an MCU, I'll unsolder it and solder another one or something like this. And if I want to check something before I have the PCBs done, I'll get the evaluation board. We'll check how the software works, and we'll go with an oscilloscope, or some other stuff to understand if it will work with the components I placed there. For example, I have on the Akira board I created, I have their ISM and the IMU,
Yeah.
which is also used in a flight controller.
Yeah, true.
And they have the ESP32 as a main MCU. I just ordered the ISM, but on the evaluation board with the pins, with the bigger pins soldered out, and the ESP32 also evaluation kit, and connected them via breadboard, just to test out how it will work.
Is I don't know, when you buy any kind of device out there which has embedded components, embedded systems configured, like pretty much anything you buy out there, do you is it like with like brands and stuff? Do you pay for the design of the whole thing? Because the components themselves are not that expensive.
No, there are expensive components.
I mean, some of them, but
Some of them.
like for instance, if you take, I don't know, like most of the FPV parts here, they're not that expensive. You just, I guess, pay for the whole streamlined process.
Not actually. If that's an FPV, a good FPV drone, and a good motor controller, the MOSFETs could be actually very expensive. Like a MOSFET could be $3 for a piece. For example, a MOSFET that is used to control the AC can be like 30 cents or 3 cents, or an MCU can be also of $6-7. For example, the newest MCU with possibility to run TinyML on this with some AI accelerator can be $30, and then MCU used in the easiest oscilloscope you can buy on AliExpress is, yes, $1 and $2.
Yeah.
Yeah, but again, the embedded system and the PCB, the all these things are in such a way, in such a different thing. So, such a lot of those things we have. So if we speak about Apple, we can't just think about this because they're going to TSMC and say, yeah,
Yeah, especially in their case, they don't have out of the ordinary components, and a lot of the times you just pay for the design, for the fact that they designed it, or
yeah,
not
but
even them.
the microchips of their microchips, their microcontrollers, their like CPUs are designed by them.
True, everything else is kind of sourced from
Yeah,
different.
but again, they are
Yeah,
paying so much. I think the Apple price is firstly for the brand, but not necessarily firstly. But on one hand is for the brand. On the second hand, they go to the Samsung display
yeah,
and they pay so much. So and they say, give me the best displays you have and don't sell it to anyone. And Samsung displays, okay, is thinking, okay, I can sell those displays to 10 companies and I will get this revenue, or to sign a one exclusive contract and says, okay, but you'll pay me 5 times more than anyone.
yeah.
And Apple is
They
like,
still
okay,
win. They still win.
yeah, then they still win because they're doing this in this way. If we go with some Samsung tag or Samsung Home thing that you let's go with the socket controller
Yeah,
and the Chinese socket controller, that will be 10 time price difference, but I think the quality differences also will be in this. And again, the not only the quality difference but how it works, the ecosystem, the servers, that so much things that works on this price and that creates this price, which is not only the actual components used, the PCB and the quality of PCB. It's also the servers, the code, the quality.
how do you source your components? Because I would assume you have a lot of choices to make when it comes to putting up a board, depending on the project, of course.
So we discuss with the client if that's
Yeah,
a client project, and if we have. The most important thing is to go with the microcontrollers and integrated circuits. There, I discuss with the manufacturers.
yeah,
If they're okay with if I'm okay with the microcontroller, I choose the microcontroller. After this, how to source them, I just discuss with the manufacturer if they sell it directly. And actually, I'm going to DigiKey and Mouser.
yeah.
Mouser is the most popular website for this, and just find the things that I need. Because if I choose a microcontroller and the integrated circuits I need, there I only need some transistors. They'll need some passive
But
components.
even in like choosing bare bones, like transistors, capacitors, like even there's like a difference in price and quality and whatnot.
Yes, but that's not so hard
It
because you
depends on
have
the application, I guess, if something is more fault tolerant or not.
you create when you choose what to put in your scheme,
Yeah,
what to put in your circuit. For example, I have the PVM from a microcontroller, and they need a transistor. So I know that I need, for example, I need the voltage controller AMS 3117 for 3 and 3 volts. And I actually know the three manufacturers that create them. And I know that this manufacturer will give me a good price. And I already know I work with this. Mostly
yeah,
it's like this. Or
yeah.
I ask my hardware engineer for this because I think they worked. And if we don't know, that's a rare stuff. But I'll ask another hardware engineer with more experience what to use. Or I'll look over the internet and the prices.
Because this eventually ends up making the price for. I mean, technically, if you work with a client, then you don't really have a say in the price. You just say, we're going to need this and that component.
No. When you're creating the PCB,
I mean, the final
design,
price.
Yeah, the PCB design.
Because they'll put like the price of the components plus the work plus whatever the brand price is.
Yeah, no, they have the special constraints. Yeah. I can say you come to me and create me this some custom stuff. I want
Yeah,
to
that's
produce millions,
subjective.
and
Yeah.
we are discussing, and I'm saying like, okay, I'll produce, and the price to produce one will be $100 per piece, and you say no, I need $10 per piece, and then I am thinking how to make the price lower.
Yeah, but then you have to compromise between like quality and what they want. So typically it's
Sometimes.
like, I want this, and then you ask them what they want, and then they tell you what they want. You're going to say it's going to cost this much. They say, fuck no. Then you go back to them and you say, okay, we can do it, but these are the limitations. And they agree, or they say, okay, let me revise the price maybe.
Mostly like discussing, but this is not an embedded side. This is a management, like,
Yeah, it's
product
still part
development.
of the
Product development side.
yeah.
And again, this specific case is a part of an embedded system or developing as IoT device, but discussing with a client the compromise between price, the speed of development, and the quality is part of any product development.
Yeah, obviously, as a software engineer myself, there's a bunch of curiosity on this topic. I'm wondering, how is embedded engineering different from software engineering? Like, what's the most critical part one would have to go into, or swallow their tongue maybe?
Me as only embedded engineer, like all the software I wrote, like I wrote some websites, some Python scripts, but it was like for fun most. I was writing only the embedded systems for production. So I think the stuff that will be hard is if you go to something like RTOS and low level stuff, you will be scared of tons of datasheets on hardware debugging, on as shit most of a lot of defiance,
Yeah.
pointers, disassembly, stack pointers. If you have a hard fault, you should like debugging in, for example, let's speak about the recent stuff to debug I had. I had a hard fault, so I have to debug something. So I have a thread created by me, like all this stuff was written by me and my team, and I have a state machine thread, like some name state machine thread, and I don't know where is the hard fault. I have a bus fault, so I have a bus fault somewhere. So I know what is a bus fault, why it can be. For example, one of the reasons some null pointer, some stuff with pointers, the most probable from experience. So what I'm doing, I'm going to I have the program counter, the stack pointer, and all these registers. I take all these registers and look at the addresses. So it's like 0x08 something.
Yeah.
After this, I go to disassembly of the code of the binary and try to understand from the disassembly of the binary. I get the address. From this address, I possibly could get the function where it happened. From this function, I could get the thread where it happened.
How do you know the function from the address?
You know
you see code. Like references of the
no,
function
no,
being
you have
called?
you have you have the code.
Yeah.
If you have a good debugger and you have the possibility to set breakpoints, okay, but this happened on the PCB where we uploaded and have only the logs to the MCU. So I can have the disassembly of the functions. So when I'm building everything, one thing where you can hate embedded systems are the build systems.
Meaning?
How you build, for example, you want to start developing with JavaScript.
Yeah.
For example, with Next.js.
Yeah.
What you have to do?
Simple. Install Node.js, compile, everything's done.
If you want to go with Zephyr RTOS, okay, with ST Microelectronics, for example, you have to install only the Cube IDE. For Espressif, you have to install the extension, the Espressif ESP SDK, the online, the GDP compiler.
Like, You mean there's like software which helps you to flash?
Yeah, the software which helps you to flash, the compiler, all these things are not necessarily came in one package. You can't
Yeah.
install it all with one command.
Yeah.
You possibly, for example, I have ported from the ST to the Nordic Semiconductor board, to a Nordic Semiconductor board, so I can't flash it anymore.
Yeah.
So I have the ST microelectronics utility to flash. I have to install NRF util. I installed the NRF util via pip install in the virtual environment in VSL. After this, NRF util was not the version I wanted, because in this version I don't have the board. I have the actual board. So I deleted this board. I go to their website, to their git, gets with the command vget from this. After this, chmod -x. After this, I want to understand, is this the version I want? Is this version having the board I have? So this one of the things can be. Another one is like from the code, how I can get. I'm compiling the code. For this type of debugging, you should understand how the code is compiled. So you have the C code. After this, you have the temporary file after the precompiler gets.
Yeah.
After this, you have compiling you get the object files. After this, from the object files, you can go to assembly files, object binary files, the actual binary files, but in files. And after this, you have linking into one binary.
Yeah.
So you should know for debugging, you should go back these steps from this to object file to the assembly, from assembly to the code. This can be done automatically, but not necessarily.
Do you have like different, let's say, development processes for, let's say, when a board is in the development phase versus when it's massively produced?
No.
Do you disable certain things before you?
No. We can enable some extra logs, some extra stuff, some extra security for development. But when the code goes like the board, actually, how the perfect world would look like is we have the research phase. We hardware team and development team, software team and hardware team is like, okay, let's go with some MCUs. Hardware team thinks what MCUs, what integrated circuits to use, what models to use, and so on. Software team tries to flash all those, some MVP software, tries all this. After this, hardware team creates the board, and only when we have the final board, we go with the software team, and software team creates the full software.
What's your equivalent of, let's say, CI/CD pipelines when it comes to software, but in your case?
It can be also the CI/CD in GitHub or workflow by building. You can't test it, actually, but you can test the build, for example. You can create a custom workflow
to test the code, basically.
Yeah, to test if it builds correctly, it's with the RAM, DRAM, and flash memory. If it fits, and it's okay. Like this is the one I saw mostly.
So are you saying debugging and the tooling is what software engineer would hate the most, probably?
Yeah, I think so, because for me, like front end, backend guys are like, they have something to install and they can work. And for me, if I can have one software that is working on one board and I can't flash it on another board without some
intermediary.
Some intermediary, a lot of stuff to do and a lot of steps to do. For example, the Akira, the console I showed you.
Yeah.
There I have the getting started README. If you want to flash it on the Espressive board, if you want to flash it on the ST board, what to install, where to go, what to git clone, what to get, and so on. A lot of commands to get started with the fully working code that I tested on all boards I support. This operating system support.
Yeah, that's fun. Do you miss, or I can't even say miss, but have you considered maybe doing software development?
I'm doing software development.
Well, let's say software development which doesn't interact with the hardware.
No, I don't like it. No.
What's the deal breaker for you?
I don't know. Like I like to understand what is happening. Like when I'm writing a Python script, I don't know what happens there. Like I'm just using some functions. I'm just writing some.
You mean like memory management?
not only memory management, like everything. And of course, I love seeing how it works. Like
So you don't like abstractions, is what you're saying?
Oh, I like abstractions when I know what is under these abstractions, when I can go there. But for example, in Python,
Yeah.
you go with any library,
Yeah.
any library for my PyMath,
Yeah. Yeah.
and some function works not as you expect. Some strange behavior. You use 50 functions from PyMath. You are doing something, and you are debugging like 5 hours in a row. You get to one function from this library, and this works not as you expect. You can't find any stuff related on Stack Overflow or Reddit. And what you should do? You should go to this function, understand how this function is written, and debug the functions inside. Can you do this in Python? No.
Technically, if you're importing a library, you could check their implementation.
Yeah,
of the
but
function.
can you, while interpreter is running, to get into this function from the library?
You mean if you're using like standard library functions?
No, any library.
So if I'm using a library, of course, yeah, I can. If I'm using a library, I go into the library source code. I check the
No,
source code.
while debugging.
I can. Hold on. I see what you. I mean, in Python specifically, no, but like when it comes to Go, because I'm using Go, you can easily do that because you can even do it with the source code, with the standard library itself. Because Go is written in Go, you can do breakpoints into the
in the library,
in the SDK itself.
Yeah, nice.
You can even change the SDK on the fly.
Is Go interpreted? I don't know.
It's not.
It's compiled. So yeah, that's why Go works like this. But again, Go is written in Go, and it's again on this level of abstractization that I work. For example, in C, I can go till the lowest level where I see the everything, like where I see everything. And that's why I think one of the points where you can't debug what I'm debugging, and I will be, okay, you can, but it will be not so, it will be different flow of debugging than for me. And for me will be a different flow, because for me, if I'm importing a library, not importing, getting a library, because actually in C, I know when I'm including a library, it actually takes the code from the header file and put this in my code.
Yeah, but it can be, let's say, operating system dependent. Do you have, like, how do you solve the, let's say, cross OS compatibility? Like, do you have problems when you
writing your own abstractization layer?
Do you have problems when you have, like, let's say, code which works on your machine and then you try to deploy it on some microcontroller and doesn't work?
Like on my machine, I'm testing on microcontroller already.
Are you already flushing it so you can?
Yeah, I can test how I can test another way. So, for example, if I'm testing on ESP32S3 and I'm trying to run it on ESP32, it will not work because of some register mismatch or something like this. I will create a compatibility layer.
So there's no virtual environment of sorts? You have to always, every single time you write something, you push?
No. There is only for Zephyr OS a native SIEM.
Yeah.
And for embedded Linux, there is something. But if you're not using a RTOS, like real-time operating system, no. If you're writing a bare metal, like low-level embedded, it's impossible.
So yeah, given that scenario, how often you choose to flash? Do you just write a lot of software and then just flash?
No, I'm flashing like in a day if I'm working on some. For example, I released yesterday. I released the Akira version 1.2.3. Before releasing it for 3 days in a row, developing this as my pet project, I will flashed 50, 100 times, maybe 3 different boards.
Yeah, because it's not like with even compiled languages. When it's software, you just run it again. But even in my case, I don't run it every, let's say you write some code, you don't run it every single time. You just, like, you can do it once an hour, once or.
No, I'm not doing it once an hour. Okay, you also don't do it once an hour. For example, you are creating a new model. You are writing 2 days in a row a very big. You're designing an architecture, creating all this.
Yeah, that's my point. You don't immediately test it.
Yeah, so you don't immediately test it as I do. Okay, I want to create some auto model, for example, to update the software, the firmware, on the fly when the devices can't be accessed directly.
Yep.
So I'll test. I'll do some small testing of PSRAM, of how I can write into Flash, how I change the banks. I'll do some small code for this. Will Flash like 10 times if it's okay, maybe more, maybe less, but I will choose to Flash. So now I know how it works. Create my own functions, my own API for this, and start working with this. As I worked, like when I started, I would create all this from the one time and we'll try, and this will be tightly coupled with the low level.
Yeah, what I was trying to say is, like with software, it's easy to iterate. Like you write a small piece, you see if it works. You write another small piece, you see if it works. And here you have to plan a lot of stuff in your head, because otherwise you're wasting time on compiling this.
That's why embedded engineers love diagrams a lot. Like as what I tend to do now in every project I work is like, if I know that I have more than one, if I have only one microcontroller, I'll create some low-level stuff which is tightly coupled with microcontroller registers, pin numbers, memory zones, memory banks, all this low-level stuff in a low-level driver specific for this microcontroller. After this, I'll create an abstractization layer where I'll have if-def SOC 1, if-def SOC 2, if-def SOC 3. And after this, I'll have with a lot of wrapper functions, which from this abstractization layer, I will use in the high level model, which is the actual logic. And all this you should create by yourself. And after this, if somebody already have the driver for example, for the flash memory and for the non-volatile memory for this specific chip,
you just import it?
No, you do not import it. You go there, go to this code, look how he wrote this code, test it, and rewrite it to your.
Oh, I see.
You can't import something here. Yeah,
no,
you can.
I thought it's like a header file which you import.
No, you can import the function. Most of the libraries are not static compiled in embedded. You have to take the source files, the header files, to copy them to your project, and to compile this. Yeah, you can do this, but it's mostly is not working like this.
Interesting. So how do you share code between, let's say, projects?
Like say the same, like if it works for ST, your driver, it's not necessarily. For example, if I'm creating an I2C driver for IMU, if this driver works with the specific Espressif SDK, with their compiler, linker, and all the stuff, and how it works for I2C, the functions. Okay, again, the functions that Espressif and ESP use for I2C send, read, and for bytes send is different than ST. So I can get this driver, import to my ST project.
By import, you mean copy?
Copy. Physical copy take. And look like ESP is using some strange I2C send. I will use my STM HAL I2C send and rewrite it. So if somebody wrote something that for your board and for your project is can be suitable, you're a lucky guy. If no, go find something similar and write. If you can find even something similar for this specific integrated circuit, you go with the datasheet and create your own driver. Sometimes it is easier to go. For me, it was easier to, for example, for the display, I wrote a driver for display. It existed for ST, for bare metal, but didn't exist for a custom OS. So it was easier for me to create a driver from the zero. I was looking like for a reference, but it didn't help me. So I get the datasheet and created again.
You mentioned this term of datasheet quite often. Is it like the documentation, the pin layout, all that?
The pin layout, the registers, the memory mapping for anything, pretty anything you can find.
Can they be out of date or inaccurate?
Yeah, a lot.
So you kind of have to trust them, and if something doesn't work, you need to guess.
You have to trust them. For example, if you have like 5 revisions of chip and you are using for some reason the first revision, datasheet can be only for the 4 and 5. But for the hardware is mostly, it is first revision, 5 revision should be suitable, the datasheet, but not necessarily. For example, we used the chip, the revision was version 0.2. and the datasheet was created specially for me because we're partners with the chip manufacturer.
Yeah.
And there was like some registers and some special byte sequences to send to this integrated circuit that was like to be,
Yeah.
to be
Yeah.
defined.
Yeah.
And we was like, we have to use this, but how? Okay,
Even
yeah,
when you
we
buy
was
like a product, they have typically they are obligated to have manuals, and you read the manual, and if at some point they released a new product, then they'll just update the manual for the newer product, but the old product will still kind of have to rely that the new manual will cover the old product as well, which is not
yeah,
the case always. Yeah. You mentioned you don't like going back or trying to go software development only because of you not having control, not knowing what's happening. What's your opinion of languages like Rust trying to take over, like Linux kernel, for instance,
no, they did.
make waves in the embedded systems and
No, no.
whatnot? What's your
I saw
opinion on
that
that?
I worked with the Linux kernel on the project I'm working now. I worked with the Linux kernel now. It's
Yeah,
nice. It's a nice tryout. It's a nice stuff. But uh, I saw a meme about PHP.
yeah,
2007, PHP is dead.
hmm
2017, PHP is dead. 2025, we're still writing in PHP. So with the C, there,
I mean, nobody neglected C's importance. I always thought C is like the super
yeah,
killer.
the guys in C, everybody tries to kill C, and for the last 30, 45 years, and
Yeah,
nobody can because Rust will again, as Python took his niche, as JavaScript they took the niche. JavaScript have TypeScript have some niche. Same niche will have Rust and all others.
is it mostly support or is it something else you don't like about it?
About Rust?
Yeah,
No, I like it, but I don't like to use. I'm not writing in this. I was just pinging in some to look how it works. Well, okay, nice stuff to look at this, but I'm writing in C. I'm writing the real code.
I don't know. I'm on the other side, especially when it comes to like gaming engines. There's like Unreal Engine, which is obviously C++, and I'm like, okay, I love Rust, and I'm seeing that it's starting to like make some waves and whatnot in the gaming industry. Some new frameworks came up, but they're not popular, not a lot of traction and whatnot. But I guess it has to be it comes down to support, like who are the companies, people maintaining, supporting, as you said, drivers,
Yeah, yeah. Do you know
tooling.
what is WebAssembly?
Yes.
2, 3 years ago, WebAssembly created WAMR, WebAssembly runtime, micro runtime.
Yeah.
Intel sponsored them, and they created the micro runtime for firstly for JavaScript. It existed, of course, and firstly for C. Yeah, they added Rust after this, but for C, it wasn't more important for them. And the Intel sponsored them. Xiaomi is pushing, updating this WAMR and so on. This the C is important because you can Rust, Python, Go, all these languages are like a machine. You go to this machine and you can do some specific stuff,
Yeah.
right?
Yeah.
You can you write in Go gaming engine?
You could, but it's not advisable because of memory management.
Can you write in Go some low level stuff? Also, you can, but it is not this.
There's a version of like TinyGo, which is like using, I guess, the garbage collector more efficiently. But still, if you want to go low level, you need memory management. And the way to go is C, C++, or Java. Or, no, sorry, not Java, or like Rust. And what else is on the scene?
Okay, and for example, Rust is also a specific machine. You go and take it to do
But you
something.
still have to do things the Rust way. You can just
But C is okay. C is not object oriented, right?
no.
No, at all. Like
It's very procedural. Yeah.
yeah, it's functional language. I can do object oriented in C. Likely, I can write my own framework. I can do object oriented C. Okay. Can I do some specific Python stuff in C? Can I create interpreted C by just using C? I can. Because C, as I said, is a toolkit, very easy toolkit. Because it's like, you have the hammer, you have all the tools, like basic tools, you can do everything with this. And Rust, Python, Go are like some very complex tool. You should understand how to work with this. And that's why Python is easier to, somebody says, in my opinion, C is easier than Python, Rust, or any language. It's much easier as language, as semantic and syntax.
I think I know what you mean. Like, you mean
Because-
maybe it's easier to understand how it works from scratch rather than to understand all the complexity.
Yeah. Because
Like it's simple to start with these abstracted languages.
Yeah, because C is hard for the all software developers that I met. Not C software developers say C is hard, because C is like, you should, if you want to make a hole, you have the toolkit to create your own drilling machine and create the hole. The Python, you can't create the hole actually, but you have this complex stuff, complex machine, complex tool to use it. So that's why you can learn how this machine works, not how to use this machine, but know how it works and do a lot of stuff from the start. But after this, when it comes to point, another variant of another analog of this, what I want to explain. Let's go to LinkedIn and look how many developers have Python, JavaScript, and a lot of languages that are in who started with JavaScript or Python from the start.
Yep.
They have a lot of languages. All of them have really 5, 7. And how many C developers who have a lot of languages, like which are EmbeddedC or writing some gaming engines, or C++ developers. C++ developers can have 2 languages maybe,
yeah,
but they're not working in them at all. They're like working in their language because they know like this. Because they know that in this language they can do anything they want. In the language, for example, from Python,
what software engineers mean when something like C is hard is, I guess, the start. So the start and the routine, that's what's the hard part. Because it's so easy to make mistakes, that's what makes it hard. And especially when it comes to software, the hardness has to do with the scale of the software. So the bigger the scale, like you take Google, Amazon, like big software companies, you cannot afford to tolerate mistakes just because the language allows you to make those mistakes. So you want some kind of a safety net.
Yeah, actually, most of the languages are written in C.
Yeah,
because it was a core team who was writing some software. They're scaling it up. They are hiring more developers, and they're like, they are doing a lot of mistakes. Let's create a language for them. And so, and I think C, everybody says C is hard because can I write a calculator in Python, like graphical, very nice UI stuff in Python that will take me like 15 minutes maybe.
Yeah.
In C, to get a graphical interface for the calculator, it's like, for a beginner, can take several days.
And that's just one operating system.
That's a Qt. That's something Unreal stuff. I don't know what is this. And that's hard because you don't know this. Because you should understand how it works. In Python, you don't want to understand how it works. You just want to create a calculator. And in my opinion, the mistake of a lot of software developers, like the monkey workers guys, they don't try to understand. They just want to create something. I want to be a software developer. I want to create. Yeah, I also want to create, but in my opinion, for me, software development is I want to understand how it works.
Yeah.
Yeah, and after this to create. But a lot of guys like this courses, like 1 month and you will be senior developer. Okay.
I think we're on the same side here because at least that's what I'm seeing nowadays, especially with this whole AI boom. So you mentioned one very important thing, not only getting to some results, but also understanding how it works. Like everybody's pushing this idea of fast delivery. We need to do fast. Let's not focus on quality as much. Like you're not rewarded to understand concepts. I'm not sure if at your company you have or not juniors. I would assume you have juniors. So how are they dealing with this problem? Because like when you, as a junior, when you come into a company and you're being told you need to deliver fast, you need to learn fast, otherwise you'll be replaced. obviously the incentive for them to learn is not as high.
No, for me, it's like you have to create something. Yeah, like you have to do your task,
Yeah.
and the code review. If you have two variants, like we take two juniors. One delivered very fast and did this with ChatGPT. The second one delivered it also pretty fast, but did this by himself.
Yeah.
And understood everything. This one was faster. This one created a pretty nice code, very clean. Okay. At the code review, I'll ask some points how this works, and I'll ask, okay, if I want to scale it up or if I want to change the driver, I want to connect this, to cut it off, to create some other abstractions, to connect with another abstraction layer, or if I want to give me the APIs right now. So I use this from the guys from higher level use this as an API, and I can connect any driver to this. How I should do it? And the guy who did
But would you
with
care if, let's say, they did a good job with, I don't know,
no, I care
ChatGPT?
about this
Yeah.
because getting a task done fast and getting the project done fast is two different things. Because every time when you at start,
Yeah.
you are trying to do a lot of tasks done very fast, and after this you have a very big technical depth, and every change will be very annoying and very hard to do.
Yeah.
That's my opinion. I want to create like, okay, I'll have 2 weeks of refactoring instead of having so I don't know what to say to the client, why we can't do the feature he wants, or why we can't change the model right now, or why we to write one driver we need 3 months. That's crazy. That's what the technical depth. And in my opinion, it's better to have 2 weeks of refactoring than after this 3 months of bad heart of because you need something to change. So about the AI, and the quality and fast and how important it is to understand. In my opinion, the this vibe coding stuff, all these things, is interpreted incorrectly because it's more important to have an architectural view,
Yeah.
to understand the code, to understand how it should work, to understand the models, and not to write everything by your hand, but to understand everything. So this is more right now. This is more important because
It depends who you ask and what industry.
okay,
Because you mentioned this idea of monkey job, monkey
yeah, the
whatever.
monkey.
This is so relevant nowadays.
Yeah,
Like
yeah,
a
like
lot of companies just need monkeys, like people who push ideas
because
with AI.
and AI will replace the developers. It will replace the monkey workers because okay, you should see in company in some companies where you work as developer, a project, 10 developers, 2 seniors or 1 senior, 1 middle, who are really understanding everything. They, for example, you don't have documentation. Who should know? They should know about this everything, and all others are every day writing the code. All day they're writing something, but they are writing as a monkey, as a ChatGPT can do right now, everything that the guys said.
Yeah,
Yeah, that
they,
will.
they tell you what to do, and then you fuck up. They tell you how to fix it.
Mm.
It's I can tell that from my experience. It's really frustrating when you have to. It's not even juniors or whatever. It's like other senior or your peers. You have to tell them this is not gonna work. You
Yeah.
should fix it because they didn't even think about it.
That's the point. Like monkey work, the coders.
Yeah.
As I said, as I named them, monkey workers. Like we have the coders and we have the developers, engineers, the real engineers. Engineer is the guy who understands how it works, understands why it works, and how he can change it. And the coder is the one who listen to the engineer and write
Yeah.
the code. And yeah, of course, in my opinion, AI will not change, will not replace the developers. But the problem is that not all of the guys who write code are developers. Actually, not all of them are engineers, because you can't have the structural view. You can't understand everything, every relation, every flow of data, all this, because in this point, embedded systems, no matter what you are doing, or in engineering, embedded electronics, software, it's anyway the how data flows or how the electrons flows. It's anyway about architecture, about how it works, how we can change it, how we can make it modular, how we can make it flexible and so on
Yeah.
and good. And
Yeah.
if, for example, if at this point there are companies that have, instead of 20 developers, 5, and they pay and each of them have the Copilot subscription with cloud Sonnet, something like this. Yeah, because these developers can create a good architecture, can create the hardest stuff which is not possible, like the logical stuff and so on. And they wrote a function, and they just asking like write this function like 5 times with these changes and so on. Because for any coder right now, we're trying to give prompts to ChatGPT and Cloud and all these AIs as we would do, like just create it. If you said about even seniors, you go to the seniors and you explain like you are writing a prompt to the ChatGPT.
Yeah. What you're saying is, in the process, we'll get rid of vibe coders / coders / monkey workers, and we'll replace them with architects.
Yeah, with the guy, like I think maybe as right now the designers and the front end developers are uniting in one.
Yeah, I mean more like let's say software engineers.
Yeah, like some software engineers right now, big companies have architect and senior engineer, like lead level.
Yeah.
I think the architect and the lead level engineers are on one level, and they will just go in one. Like architects are anyway a software engineer that is now doing more overview over all the code, and the software engineer is also, he's managing a lot of coders.
Yeah. Yeah.
When there will be less coders, we'll have software engineer, this lead level software engineers and architectures and architects in one profession. That's all.
Yeah. So the coders are the first line of disposable people, basically. Yeah.
So that's actually, if we look over the years, over the history, and if we can say the AI, IoT, and all this edge stuff, fourth industrial revolution, the third industrial revolution had the same stuff. In the Great Britain, the guys who were working on the factories got the hammers and tried to break up all the machines.
Yeah.
Right now, some of the developers are writing, AI will replace us, AI is shit, we can't work with AI, and that's the same thing, but not via the hammers and breaking it physically, but via
Renting.
yeah,
Yeah. Yeah.
same thing. And in same thing, there from some guys who were working at we can name them engineers. Also, they were thinking they're engineers.
Yeah.
The guys who were just cutting one bolt all the day, like whole life. And then the same way is the coder right now is also thinking like he's cutting one bolt or one piece of code all the life.
Yeah, as somebody said, you need to wear more hats. You need to be more generalist. You need to be more of an architect, visionary, maybe product designer and whatnot, instead of just coding. Coding is becoming a commodity.
Coding is like a tool.
Yeah, anyone can code nowadays with AI. Can you make it make sense? Can you put it to good use? Like the problem I see with all of this AI being used and overhyped is outsourcing your critical thinking skills. Instead of you thinking, you understanding, you taking the decision, you just ask, how should I do this? How should I do this? And then you just trust the decision and the decision making and whatnot.
Actually, when as I'm using it, I'm thinking how this should work. I'm creating some flow, some diagrams in Mermaid and so on. And after this, I'm like, okay, I have this driver, create a new one, but change it. And I'm like giving a big prompt, what to change.
Yeah, but you already give it enough context.
I know how to write this already. I don't think he will create this instead of me.
I just outsource routine instead of thinking.
And that's the point of AI. That's the point of all machines. That's the point of the 3D printer. Like the 3D printer, AI, the machines, like all these things are not meant to create instead of us. Are meant to.
Yeah, we should use our time better.
Yeah.
And if you use your time to like waste it on routine is just like you don't have enough time, enough energy. You just need to focus on something more productive. And just remembering a function by heart or how to implement an algorithm, that's routine basically. You can just outsource that.
Like I remember that algorithm. I can write anything right now.
Exactly, yeah.
Yeah, but the bad point about the juniors you said is that they think they can learn with it, but ChatGPT is meant to write code instead of them not learning, and they're not asking how this code works, how my code works, review my code or something like this. They're asking, give me
The solution.
the solution, and
Yeah.
that's bad.
Yeah.
And I think if we had the ChatGPT at our time, because all of developers, everybody who started software developing was thinking how to create this faster, how to make it work. And if you ask ChatGPT how to make it work, you ask the
I think
question.
we've transitioned from the time. I remember the times when we used to value quality and we would compete who has a more higher quality software, like clean code, architecture, best practices, design patterns, all of that was a thing. Nowadays, delivery speed is the main thing. And in the process, you are making a lot of monkey workers, which at some point will be discarded. And yeah, that's the tough part, I would say.
Again, as I said, looking at the history all the time, something like this
Yeah.
happens. That's the
Yeah,
first time.
I also agree with the fact that we're probably at a industrialization 2.0. I don't know when the phase of disposal of manual labor is going to happen. I think it's already happening to some extent, maybe not as fast as some people want.
Even in Moldova, we have
Moldova is like
Toreco
it's catching
company.
up, but like 5 years later.
Yeah, but even Moldova, we have Toreco robots that give you water and so on. And in Japan and China, there are robots. There are like
Japan is like from another earth. It's
yeah,
so
yeah.
advanced when it comes to a lot
What's
of
the time
countries.
right now in Japan? Like 300 years later.
Yeah. No, it's so advanced. Like even like when you go to the bathroom, compared to many countries. Yeah. Um, you mentioned the refactoring and whatnot. I was wondering, do you always write code from scratch, or do you sometimes inherit code when working with clients?
I'm using we can inherit code from the client,
Yeah.
but I'm not writing. For example, I have like I2C driver or
Yeah.
some specific chip, and if at some project I need same, I'll use just what I wrote someday. Like reusing the code is the most important.
No, what I
Why?
meant, I was trying to make the parallel to software, because sometimes like you're like a client comes to you, you're, let's say, an IT company, they come to you, they say, we have this software, we like developed it with
Yeah,
one company, now we want to continue developing it with you
yeah, it
because we think
was something like this.
yeah, so you inherit like really bad code, really shitty code, now
Yeah,
you
yeah,
have to
yeah.
deal with that shit.
The code that you better
Exactly.
burn and create a new
Ex-
one. Yeah, I
ex-
don't
ex-
like to work like this, but it happens.
yeah, so you have that same scenario.
Research this code, we understand what they need, and if they have money and time for us to create and refactor this code fully and create something good, okay. If no, not my problem.
Yeah.
I will implement these features, but I will implement this as a separate model, very like modular stuff, and just give the APIs and call them from your code, the code you gave me. And, I'll say this to them if they are not okay. I'll say them if I or I will refactor the code you have, and we get a pretty good code, pretty good project, or I will create my separate model and will implement it like this. Yeah, it will be tight coupled, it will be called directly and so on. But anyway, I want to create this to show that, so I have the possibility that my model separately on this specific board works properly and so on. And the problem is then the code you gave me, because if the client come and he say my code is good, please add something to this, I will do like this. That's normal stuff. Because for example, you come to me with this drone and say my drone is good, but please add something. I will add something to this specific board, for example, communication board, for example, with the FPV goggles.
Yeah.
I'll create this, we'll this on a simple drone. I'll show you this works, perfectly works, that's nice. I'll put it on your drone, test it. If that works bad, that's not necessarily my fault.
So I'm sure you already have like a huge experience behind. I was wondering, what's one hardware magic that still blows your mind to the day?
I don't know.
Like something maybe which caught your attention early on when you started, then you kind of progressed in your career, but if you think about it, it's still
The semiconductors, I think. Yeah, I fully understand how this thing works, but I'm like,
How do you plug something into the socket and then
no,
you
no, no,
get zeros and ones?
no, not that.
No, not
Zeros and ones is the easiest part of this.
like that's still mind blowing
how
too.
on the quantum level you take a piece of rock,
Yeah,
cut it, add some conductive or unconductive stuff, you
yeah,
create a semiconductor. And how the you get to the point where you want to take a rock, a piece of metal, and do like this. And after this, you want to try to go with some wires and 20 volts with this, and you understood like how the guys come with the idea to create this, because the first semiconductor was very big, like it was like this,
yeah, yeah.
the diode, and I was like, okay,
Yeah, when I started, like, because I was always curious like how memory works, how memory, so you go back to C, then you go back even lower level than C, and then like, okay, what, and then in your mind, because as men we always have this Roman Empire type of thing where we think about some shit always, like creational stuff, some genesis and whatnot, and then you start thinking about memory and your mind goes back to the socket. You plug some shit into the electricity, goes through, electrons uh, flow through that
yeah,
wire basically, and then you get zeros and ones. And then zeros and ones is what memory is being represented as through the form of pictures, videos, and everything we consume nowadays. All of that is fascinating to the day, even though I'm flawlessly
no,
using
but
this.
that is so used right now and
Yeah,
so not understand it that but actually for me that's not something like I like it, that's fascinating, but not something impressing so to blow my mind, because I fully understand this, like 0 and 1, okay, how to save this in memory,
yeah,
because we have logic gates. The logic gates can be created in transistors. The transistors are specifically passive components or in diodes. The first I found at Ptichka, actually, Soviet Union created memory chip, which was you are able to write it electrically, but to erase the memory is not possible, because there are not transistors, there are diodes that
yeah,
are just blowing up
yeah.
to write 0 or 1. So I created my own RAM memory, 8 bytes, and actually in university you are also doing this, but nobody explains you this.
Yeah,
And
when I read
because
about how you basically write, erase, and read memory from the RAM, it was very fascinating. Especially how you write, like you have to apply a higher voltage or
yeah, and there are two resistors,
yeah,
two transistors, and they're like all the time like this. You applied this, after this you unplugged it, and because it has power, you unplugged the logic, this adjusting stuff, which is writing actually. It is all the time going from one transistor to another because they're opened. When you are opening the third one, there you can read or and erasing and writing are from other side.
so is it true if like if you're erasing some let's say SSD way too many times, it's gonna degrade?
Don't think so. Like SSD is created on micro, not on like the HDD can be, because HDD is like a physical, something physical writing as
No, even
vinyl.
even the process of like erasing due to voltage always being applied in order for to zero out the space.
If you are erasing everything, right,
Yeah,
like
yeah, yeah,
all
yeah,
the page,
yeah,
maybe, but it is so small chance. Like it can be, but the SSD have so much read and write cycles that I don't think so. And again, the read and write cycles are already not electronics, are already it's a part of electronics, but it is more low level
yeah.
than
No, it's still
it's
electricity.
still
Yeah,
like understanding how the specific silicon type here in this SSD will act under this voltage, under this specific voltage, under these times, and under that's so much of
yeah.
physics.
For me, it always was fascinating. How do you erase a specific byte? Not everything, but a specific byte when they're all in this state of 1 or 0.
Yeah, that's
Because
because
you have to be careful what voltage you apply to what transistor, so that you change only that state and not everything else.
that's why we have RAM, which we can do this,
Yeah,
and we have ROM where we can read by page,
yeah,
write by page, and read by page, write by another block size, and erase by also the page. So because in ROM, like SSD or something like this, you can read, write, and erase by bytes or by word, because compiler doesn't know about bytes. It knows word size,
yeah.
which is 4 bytes for 42 bytes bits microcontroller. So ROM is cheaper because it's built a different way. The RAM is more expensive, much expensive, because it's built another way, and you have more flexibility, but it is not memory volatile.
What's your thoughts on quantum computing?
It have a place to be, but it is another type. Again, we have our computers.
Yeah.
They will continue to develop. We'll use them, and quantum computers will be for another purpose. For example, in quantum computing, we can do something very fast that will take 5 years for this PC, and on this PC we can do and run an application very fast that for on quantum computer will be like also 5-7
Yeah, but
years.
the applications, at least at this moment in time, are limited, and some people are afraid of like breaking the internet security, but that's not relevant because there's already algorithms for post quantum algorithms, and even like, I don't know, AES 256 is, I think, unbreakable.
I can break it. Yeah, I can. But
Yeah,
does it worth it? No.
it's just for you to find the
Yeah, and it will take so much time that no sense. So about quantum computing is like, again, quantum computing that we hear, it's marketing. The quantum computing, the real one, is another type of computers, as we had.
Yeah, but it's not available at like as you have it with consumer PCs, for
Yeah,
example.
sometime it will be.
And
I think
what's going to be the time when that becomes available? That's
nobody
for us to
knows.
know. For now, I think you have like applications in the cloud, which they can be costly, and you have it limited to certain applications, I would say.
For me, the quantum computing, and for what I wanna know about this topic, is like it can't change, it can't replace. It's just another type. Like
Yeah,
we have cars and we have planes.
yeah,
Planes replaced cars? No, of course no. We have cars for one purpose, planes for other purpose.
yeah,
And again, in at the moment before, like 1 year before, 1 month before the transistor and semiconductors were discovered, the PCs, everybody were thinking from about the PCs like, no, nobody needs them. This is a very big machine on
it was
lamps.
just a calculus machine
Yeah,
back in
yeah,
the day.
that it is built on lamps, and nobody will buy them never in the time. And after this, so I don't know, maybe 20, maybe 50 years, maybe 2 years, maybe in one lab, same as in Bell Labs, the transistor was discovered and was created. Somebody will create some quantum for quantum PCs, quantum computers.
It's just too
Yes,
expensive at the moment.
some stuff,
Yeah.
some small piece, like very small piece that will change the game fully.
Is the Moore's law gonna break at some point?
I don't know,
The,
maybe.
the computational power doubling.
Yeah, maybe it will break, but no, again, nobody knows. It is already step by step breaking. It's not so fast, because again, Moore's law is based on the time when Intel and all these companies started, and
Yeah.
then the technology of creating these chips was so fast developing that Moore's law was working. Right now, not necessarily, but maybe it will not broke. And again, some new technology will appear, not based not on lasers, but based on some stuff, but that we don't understand now. We even don't expect to exist,
Yeah.
because 20 years ago, expectance to use this type of lasers with this type of mirrors was ununderstandable by humans.
Yeah.
and that's all. Like all those propaganda and marketing about that will change the game, that will no. I
I mean,
think I
there's always
from
hype.
the engineering purpose, I understand that the game can be changed only by the thing that we can't understand right now. We not understand. We can't imagine it because it's not on our level of understanding of physics and laws of nature right now. Same as quantum physics and quantum mechanics. Like
Are we producing the smartest people as we used to for us to go next level? Given how people are, I would say, becoming dumber.
no, I don't think that people are uh, becoming dumber. All the time, dumb people existed, and
Yeah,
all the
but
time, genius existed. And right
who's
now,
rising up to the occasion? Like who's gonna be the next, I don't know, Einstein, the next
some guy who nobody knows
like those
about.
people are born once
No, no, no. We
in a
don't have the
hundred years or
statistic
so.
about this because we have Hawking, we have Einstein, we have Oppenheimer, we have a lot of, we have Bohr, we have this. I forgot his name. He the father of electrodynamics, and there are a lot of guys, and we have no statistic when they are born because. And right now, who will be the next Einstein? The guy who is not staying in the Instagram showing himself like, hey, look, I'm in the lab. No, he is the guy who doesn't have Instagram and staying all the nights up in the lab trying to do something. This guy. And again, about Einstein, nobody knew
Yeah, like
about.
when it comes to software alone, I'm afraid we're not gonna have another, I don't know, Linus Torvalds in the next 100 to 200 years. That's my state. Like I will not be
Maybe.
alive by like in the next, I don't know, 100 to 200 years, but I can say that like there's this cycle where good people
Create bad people and bad people
no,
create
good people create
bad times.
bad times create strong people create good times, and then good times create weak people. So we are at the stage where we have good times, we are quite prosperous as a nation, but we have weak people, dumb people, people who
I
will
think about
eventually inevitably create bad times.
I think about that we have not necessarily bad people or weak people. We have because of how fast we can get the information, TikTok, Instagram, all the social media. The point is that being dumb is now
A normality,
nice.
yeah.
Yeah, is now nice because everybody look at me. I want to be dumb. I am dumb. You know, you don't want to be dumb. You just don't want to learn. That's the point. In my opinion, as everybody knows, as every like the Maslow pyramid, there is like we have the closed, the physical stuff, all these stuffs, and the second level from the top is understanding, belonging to a group of people, understanding by being understood by people, and those like the lowest level, the interior for every person in the world. They are trying. Before this, we had the how to be part of the group.
Tribes.
To be part of the group of engineers, I want to be an engineer, so I have to learn. But right now, no, I'll not learn. I will just create my group of people.
No,
Okay.
but dumb people have always existed. But what I see is nowadays, like this, the popularization of the term ADHD,
Yeah, yeah, yeah,
the
yeah.
like the
All this shit.
dumbness is rising and rising, and you add AI into the mix. Everything is easily accessible to everyone. People get this instant feeling of accomplishment. They did something really fast. They didn't even think about it. They actually forgot what the fuck they did, and you become this monkey who's stupid, unable to to evolutionize and get to the next level. And then you wonder what's going to be the next generation that we're going to give birth to. Is it going to be smart people who actually take us to the next level of innovation, or is it going to be people that create shitty times for the newer generation?
Maybe, but
Yeah.
like it can be any of this. But the problem is, in my opinion, that sometime for firstly, dumb people are easier to manipulate, and right now everybody tries to say that you don't have to work hard, you don't have to hustle a lot, you don't have to learn a lot, you can just create something, be yourself.
Yeah,
Fi-
manifest the
yeah, yeah,
universal
yeah,
created.
go please, and understand, but to because that's the point. That's the point that not only the people are involved in this, but all these startuppers, all these believers in Steve Jobs, that Steve Jobs created this in one night. No, Steve Jobs worked as
I
a
mean,
lot.
he was also a dickhead to his
Yeah,
employees, but that's what also drives innovation in a
yeah,
way.
yeah. He was a dickhead because he was working a lot. He was looking for investments. He was doing all this shit. He was not staying in the SL from the start.
Yeah,
He
he was
was not saying,
filming a video
yeah,
on
give
Maldives.
me money and that will be okay. He
Yeah,
was going and saying and about this his style. No, at the time when he didn't have Apple, as we know Apple,
yeah,
he was wearing a very good shirt. He was wearing right the thing, right the clothes that investors wanted him to wear. And
yeah,
that's all the point. Because all this, yeah, I'll be like Steve Jobs, I'll go out of the school and will not learn everything. I'll find my voice. No, Jobs knew a lot of stuff. He was not a very good engineer, but he was understanding because in my opinion this project manager courses where you don't have to know any software development, no, you have to know, you have to understand because not Steve, Churchill,
yeah,
when he became the minister of the navy, he took 6 months of learning, of course not really courses because there are no courses, but of 6 months to learn everything about navy, how it works, to go to some ships to understand, because he was a manager. And for me, to manage, like I'm a product manager, I worked as a project manager, I'm right now have a product manager role also as a CEO, and I can't manage like your team of Go developers. I don't understand what you're doing, and I'll be that's that kind of developers you see on TikTok, like that kind of products like you see on TikTok, and they're like, "Well, how much time you need? 2 weeks." And you are going and have 5 projects more because I believe that it's 2 weeks, not 2 hours.
yeah. It's I don't even stay on that platform. It's just retarded and stupid for me.
Yeah, and that's all these things that you can be anyone. Yeah, you can be anyone if you try hard. The and mass media, the social media, and all these things try to give us the belief that you can be anyone in the very fast way.
Yeah,
No, I believe that anybody of us, anybody with nobody is like the best in the math from the birth.
yeah.
Yeah,
Typically,
you can.
fast money comes with slow problems. And since you're also the owner of a company, can you maybe reiterate again how important is consistency, dedication, grit, and hard work as opposed to just, I don't know, motivation and manifestation and all this bullshit which is being
Yeah,
propagated?
in my opinion you can't like I heard a lot of times on hackathons when I was younger, like I'll create the idea and they will give me money. No, nobody will give you money. You
Yeah,
should work hard every day, and you'll get money only when you can prove that you can create this product, because an idea have everybody,
yeah,
the will, the power, and not the power, the will, the knowledge, the understanding of the product, of the market, of all these things. Not everybody can have, but you can have it. You have this idea. Take your PC, because only the PC you need. Take your PC and try, learn, research, and try more. Yeah, the idea of I will create it fast and will give this to users is nice, but not to take money from this, but to understand what a user needs and all these things, because that, yeah, that is the point, because all these things are true, all these beliefs are true in essence, but are very bad understood and very bad showed in the social media.
yeah, yeah. I definitely agree with the fact that there's a lot of hype. And I used to believe that myself until I tried it on my own. It's like I'm not running a company. I'm like I started a YouTube project and I started doing some other side projects. And the idea is you're gonna get to a point where you get off the hamster wheel, which is 9 to 5. But in reality, you actually work more, you dedicate yourself more, and you kind of have to pick your poison. It's hard to be poor. It's hard to have a 9 to 5, but it's also hard to be an entrepreneur, somebody who owns
In my
something, who's
Yeah,
changing the world, basically.
like I know guys who in 9 to 5 have more money.
Yeah.
But I don't want to be the guy who is like, I don't care what I write, I don't care what product I create. I want to create, I want to make it. And at the moment when I was going from just working at the project to running my own projects and speaking with clients and building my own team, I was understanding, but that the first time it can be less money that I had
Yeah.
than I had, and I'm going not for a lot of money. I'm going because I want to create something, I want to build something, and I want a team and a company that is creating, understanding user needs, understanding client needs, and is not just okay. There isn't some open source project, just like take it and make it fast. I don't want to make it fast. I
You
want to
also can
create it.
scale up that idea better. Like when you are just a monkey worker, a person who just codes, you become a nobody once you get disposed of. When you're a builder, a startupper, somebody who creates something
And
meaningful, you actually have a name. You become a name. You can also increase your revenue. Like, yes, you start
in my
with some.
opinion, being a builder is not necessarily running your company.
True. Yeah,
Yeah,
the
you can
company is
be.
just the
Yeah,
legal
yeah,
aspect
yeah.
of it.
Just
Yeah.
be a builder and don't think what my boss will say, how money I'll take. Just be a builder. And if you create a very good product, if you go to a management and say, hey, listen, this is shit, but I have the idea how to make it better. You'll be a builder and you'll increase your revenue, everything you said, but in a company that you like, and this will be your comfort zone because it's not necessarily to go out of this. Yeah,
No,
you'll be comfortable.
yeah, 9 to 5s typically don't reward that mentality. I'll be all the way honest.
Yeah.
If you come and say this is shit, let's do this thing, like nobody.
One point I want to
Yeah, yeah,
mention: 9 to 5 and companies don't reward this mentality because of
mediocrity.
workers. Not only because of work, the mediocrity was created because of workers coming and saying, "This is shit. Make it other way." What way? But if you came, for example, if you go to any boss and say, "This is shit," but I have not only the idea that, but the way to make this better, and
Yeah.
here it is, and here it is why is better, not just I believe I am the best.
No, that's true.
Yes,
Like
you
you
should
don't have to be
yeah,
arrogant. You should come with solutions. True, but at the same time, like it very much depends
on the size of
who's
the
in
company.
charge, right? Because you might come in and say, "Hey, I have this idea how to make this better," and you might start to be pushing innovation, pushing better ideas and whatnot. But you have a management who likes it this way. They like the comfort zone, and they probably made a mistake when they hired you. So what happens in the industry when hiring people, like A and B players hire C and D players? They don't hire people who are better than them. They hire people who are easier to manipulate, easier to manage, and
That's in
more.
the big companies, and not the A and B players are bad managers that don't understand, that think that they are replaceable.
Yeah.
That happens in a very bureaucratic and some
Even
bureaucratic
even
machine.
smaller companies, I've seen that
Mm,
way too many times.
I don't know. Like in my opinion, I will hire some if I am bad at hardware. Like I'm not the best at hardware. It's actually I'm not the best. Like I can do. I'm like a middle level hardware engineer maybe, but I need a senior. I need a senior engineer, senior this, and I'll hire better team, uh, and will give him not only the money and but ability to show himself, ability to say to me that how to better, how to, and I will learn from him. He'll learn from me, and this is.
No, that's a healthy approach. What I'm saying is you see less and less on that, and that's the alarming part for me personally.
No, I saw this, and
Yeah.
at the company I worked, not the company I worked in Moldova, the company I worked before I started my company.
Yeah.
It was a startup, and they're okay with me working remotely. And the guy Steven, the CTO, he is like, uh, he was. I'm working with him still now, like as a developer there,
Yeah.
and he's like 14 or 15 years at Microsoft worked.
Yeah.
At Schneider Electric, he has a very big experience, like much more time, much more than me. And he was every time like, okay, we should do this, we should create this. This is the architecture. But Artur, if you have some ideas, come up, create the ideas, create your solution, and let's discuss it. And that was the the best approach I saw, and that is the approach I want to learn and understand.
No, that's perfect. I'm all for
Yeah,
that.
I love this project, and even if I had opportunities like to right now to be a developer, or because I didn't have an embedded developer right now, and I was if I or I go to that project and be a developer there, and I'm the boss there, or I'll just manage my team and will be a developer here. I choose to be a developer here because I have to learn what to learn there.
There's so much more to talk about, dude. This, like, I've invited somebody that I'm learning so much from, but I kind of want to go to a closing maybe, because I know you gotta run, you gotta make things
Yeah.
happen. So I'll maybe go to a closing and ask, is there anything outside work, as we've been talking so much about work? Is there anything you enjoy doing outside work?
My hobby is my work actually, and
You're a
uh,
hustler.
yeah, I work really a lot, and that was the time when I was at 6 o'clock, six and in the morning at the office, and at 9, 10 going home. But now it's better, but because I'm working from home also. But no, I love a lot of things to do, not only work. I love playing poker. I love racing actually, some
Racing.
drifting racing. Like yeah,
Is it like in real life or simulators?
no in real life.
Oh, really?
Yeah, yeah, of course, only on the special places, only nothing breaking the law, never breaking
Yeah,
the
yeah.
law. I love shooting.
Interesting, interesting. You like hunting and stuff?
No, no, no.
Or just at the range?
Yeah, the range. No, I don't love hunting.
Interesting. Yeah, in that case, like I said, it's been very interesting to talk to you, and I wish to continue, but I gotta let you go. And before I do, I gotta ask you, because I ask this everybody, what's your final piece of advice for anyone who's watching? Maybe there are people who have no fucking clue about embedded systems, but they really like the idea of having the power to change everything you want down to the lowest level systems. Maybe there's already embedded engineers watching this. Maybe there's managers watching this, people running their companies watching this. What's your piece of advice to them?
Understand it. Like try to understand. No, to understand everything is impossible, but try to understand and to not just do your work. No, to understand why you're doing what you're doing and why you're doing this.
Yeah.
And then it can be in management better. It can be in embedded systems. And even if you don't know anything, you should understand something.
Yeah. Really, really great piece of advice. I would recommend the same to most of my peers. And on that note, I want to end this by saying this was VUnstaged. It's been a pleasure and honor to talk to you. Nice to meet you again.
Nice to meet you too. Thanks for hiring me here.
Yeah, and I would love to do another one because I still have so many questions open.
Yeah, we can do.
Yeah. So yeah, this was the Unstaged. Keep your mind open and your source unstaged.